Hello everyone, I'm Nagraj. Welcome to my first video. In this video, we'll talk about how to install ONNX Runtime on Raspberry Pi. Whatever the videos I upload in this channel will be related to deep learning, neural networks, and how to run neural networks on edge devices and more. Let's get started with today's video. What exactly is this ONNX Runtime? ONNX Runtime is an inference engine. When I say inference engine, we are focusing more on testing our model or deploying our model. So we have assumed that we have already trained our neural network on any other platform like Colab or Kaggle or on your local machine, and we've already got a good model. When I say good model, my model is performing really well on the test dataset. So whatever the task it may be and whatever the dataset that we are using, my model is performing really well on that particular dataset. So once I have this model saved, I'll take that model, which is usually in .pt or .pth file if you're training using the PyTorch framework, or in any other format depending on the framework of your choice. So once you have this model, you can use that model for your deployment, right? And today we'll take that particular model and we are deploying on Raspberry Pi, and that is where inference engine like ONNX Runtime comes into picture. So this ONNX Runtime has been developed by Microsoft, and if you go to their website, you'll find all the details about what it actually does. There are two important things that comes into picture when we talk about deployment. One is the accuracy, and another thing is the speed. So the speed with which my model gives me the output, it has to be really good. It has to be really fast. And these are the two things that inference engines they're really good at. So ONNX Runtime transforms our neural network in such a way that we get good results and we get faster results. So you can go through this website and you can find all the details here. For example, the optimization and acceleration and how it actually modifies our graph, and how it removes nodes which are not used, and how it removes operators which have no effect on our model and everything. What we are interested in is the GitHub page. We'll go to that. Yeah. So our goal is to install ONNX Runtime, this inference engine, on Raspberry Pi. It is a pretty lengthy process and it's a bit complicated, so we'll go through each and every step. Once you go to their GitHub page, and if you come down here, you'll find all the details, what ONNX Runtime is and what are the advantages of ONNX Runtime, how to get started with it, and how you can install on your CPU and run deep neural networks, deep learning models on your CPU itself. You'll find all the details here. What we are interested in is, go to this Docker files. If you go to this folder, you'll find different Docker files corresponding to different platforms, and if you come down here, there are Docker containers available, Docker containers that can help you install ONNX Runtime on different platforms. For example, CPU, OpenVINO, ARM32v7, NVIDIA Jetson, TX1, TX2, Nano, Xavier, and everything. And ARM32v7 is the one that we want. So let's go to that page, the instructions page. We'll start from scratch, that is, we'll discuss about the operating system that we're going to use for Raspberry Pi. So in the very first line itself, it has been clearly mentioned that we want Raspbian Stretch. So that is one thing. Let's just keep that in mind. And the very first instruction is to install Docker on your Raspberry Pi. So there is a link given here. If you follow that link, you'll actually go to the Docker page, the document of the Docker page, and you have to install Docker from here. And depending on the OS, it is of course Linux, and we'll choose Linux. And if you come down here, you have to choose Raspbian. If you click on that, it will take you to a different page where there are again prerequisites and OS requirements for a Raspberry Pi, and they have mentioned that we require Debian Bursted or Raspbian Stretch. So we'll take Raspbian Stretch. We'll consider Raspbian Stretch here because it has been mentioned there also in the ONNX Runtime instructions also. So let's go and get Raspbian Stretch. If you go to this link, you'll find all the previous operating systems that have been released for Raspberry Pi, and from here you have to select the Raspbian stretch. So let's select the latest version. This is Raspbian Buster. Let's go back to a previous version. Yeah, this one. So once you go to this link, download the .zip file, the Raspbian stretch.zip file. I've already downloaded it and it is around 1.1 GB, so it's gonna take some time. And once you have that, you're gonna need another tool, that is the Raspberry Pi Imager, which helps you to make your SD card bootable. And you have to download this from the official Raspberry Pi website. I'll give a link to that in the description, don't worry about it. And here choose the OS that you just downloaded. Don't use the default OSs available here. Go down, choose custom, and wherever you have downloaded the Raspbian stretch file, give a link to that. So here it is, .image file. It is around 3.2 GB, I guess, after decompressing. So select that and click on the option write. So once it has been written, you're good to go. Take that SD card and plug into your Raspberry Pi, so your Raspberry Pi will be up and running. And after that, let's go back to the Docker installation here. Yeah, so we have the Raspbian stretch installed on our Raspberry Pi. And if you come down here, if you go through the installation methods, there are multiple ways to install Docker on your Raspberry Pi, but for Raspbian OS there's only one option available, that is using convenience scripts. So let's go down. Okay, so follow these two commands. Don't add the non-root user this option, don't use this command, right? Just run these two commands, and after that run docker run hello world. So it is just to ensure that the Docker is installed perfectly. Yes, docker run hello world perfectly runs, and you can see it has been clearly mentioned that Docker has been successfully installed on Raspberry Pi. So we can go to the next step. After this, you have to install the QEMU user static package on your Raspberry Pi. It's a simple one-line command, and after that just create a build directory, ONNX build directory, where you can build your ONNX runtime. After you have created this directory, you have to save this file, dockerfile.arm32v7, inside this folder. I had to make some modifications for the Docker file that they have provided. These modifications were small, but they are really significant during the build process. And I've already uploaded this updated Docker file in my GitHub repo, and I've given a link to that in the description below, so you can directly go there and get the Docker file and save it in the build directory, right? So once you have this file saved in your build directory, you can directly go and run this command. Let's see what it does. So this build, this single command will take a lot of time, and it took around 40 SAN hours on my Raspberry Pi. And finally I have got my wheel package, the ONNX Runtime wheel package. Once you have that wheel file, you're like you're almost 80% completed, right, in the installation steps. Why I say 80% is, once you have the wheel file, you have to install it with pip, and after that you have to test it. So let's list out the images that we have that are already available, and all these commands we're just gonna shift the wheel package on our local machine. So after you do that, after you've got the wheel package, you can directly install it. We've installed ONNX Runtime using the pip3 install command, and once we have ONNX Runtime running on our Raspberry Pi, we can directly go ahead and import it. Before doing that, I'll just check my Python version. So my Python version is 2.8, I guess, 2.7, and Python 3 version is 3.8. That's what I want, because while installing ONNX Runtime, I installed it for the latest version of Python, that is the Python 3.8. One more thing that I have to make sure is the pip3 version. Let's say you have the default version of Python installed on your Raspberry Pi, that is 3.5. Your pip3, it has to point to the 3.8, Python 3.8 version. So you have to make sure that as well. So we'll directly go ahead and start Python 3 now. So I'm importing NumPy, and the next thing is the ONNX Runtime. So let's do that. Okay, okay, there is no space here. Let's check this. Yeah, so I am able to import ONNX Runtime perfectly. Now let's go ahead and use ONNX Runtime for testing a model that has been trained on a particular dataset. I've already trained a deep neural network that can do digit classification using the MNIST dataset, and the code, everything, even the model itself, everything is available in this GitHub repo. You can find the link to this repo in the description below, so you can directly go there and get the ONNX model yourself. I've already downloaded it, so I won't be downloading it again. Once we have our model in ONNX format, we can directly use this model in our script to test the ONNX runtime installation. Let's check the path. So here is my model in ONNX format. Now let's create a simple script that can take this model in ONNX format and run an inference session using ONNX runtime. I'm importing the NumPy and ONNX runtime libraries, and after that I'm giving the path to my model in ONNX format. Let's create a ONNX runtime inference session by passing the path. I'm using NumPy to create a input of random values, and the size of this input is 28 cross 28. Why 28 cross 28 is the images, all the images in my MNIST dataset are of size 28 cross 28. And I'm just ensuring that the type of my input is float32. After this, I'm just going to reshape my input so that it matches with the size that I used to convert my MNIST model. It has to be 4-dimensional. First dimension indicates batch size, second indicates the number of channels, and then height and width. Now I'll take this input and convert it into a format suitable for my ONNX runtime inference session. Now we'll take the ORT inputs that we created and we'll pass it through our model. And after this, I'm just gonna get the output from my ORT outs. Let's try to run this. Okay, I'm getting an error and the path must be incorrect. So let's correct that. Yeah, that's it. So I'll just print the path and I'll just print runnings just to indicate that my session is being created. Let's try to run this now. Okay, I am getting a segmentation fault. Let's see what it is. Segmentation fault basically indicates that my program is trying to access some part of the memory on my Raspberry Pi which it is not supposed to. Let's see how to debug this issue. So after doing some research, I came across the concept of graph optimizations. Graph optimizations are basically the modifications that my ONNX runtime does on my network. So if I disable all these things, all the graph optimizations, I should work fine. And there are basically 3 levels of optimizations that ONNX runtime can do, and all these optimizations are enabled by default. So I'm just disabling all the graph optimizations. I've written a separate script and I'm printing different statements. So after creating the session, I'm just printing session on and I'm printing the session object. And just to make sure that my input is of right shape, I'm printing the shape as well. So let's run the script, Python 3 ONNX runtime mns.py. I hope it works. Yes, it is working perfectly fine. So it is running and the session is created and I'm printing the session object. The input is generated and input shape is what we want. And finally the predicted value, it has got 10 values. And why 10 values? Because MNIST has got 10 classes. That means I've got 10 neurons in the output layer of my neural network. And don't worry about these output values because I've randomly generated my input image. So these are all random values. That's fine. Now let's try to calculate the time that my Raspberry Pi takes to run an inference session on a single image. I have written a separate script for that as well. I'm using the timeit library to calculate the time that my inference session takes to generate the output, and I'm calculating the time between these three lines only. So let's see how much time it takes. So running my model inside ONNX Runtime inference session takes around 0.06 seconds on Raspberry Pi, which is really good. And of course this model is very simple and the image size is small, but 0.06 seconds on a Raspberry Pi is really good. In this video you got to know how to install ONNX Runtime on Raspberry Pi and also test it. Go ahead and install ONNX Runtime on your Raspberry Pi. If you get stuck somewhere or if you have any questions related to this video, you can ask them in the comments below. That's it for now. I'll see you guys in the next video. Thank you so much for watching.